Ben and I have been working on this topic and on having discussions about what to do and in what order on the moon for what is it now? Year and a half.
Yep. Yeah, about a year and a half. Yeah.
Thereabouts. Yeah. And Ben Smith, I guess it is an independent lunar settlement scientist and the founder of Lunar Homestead, which is a very good and informative website. I recommend anybody to have a look at.
Well, thank you.
And his view with that is to essentially make a colonizer kit that could be put together or possibly even sold to lunar settlers so that they have something to work with when they first arrive. And yeah, that's about that, I think.
All right, well, I'll just jump.
Take the floor in the air and talk about it.
I will just jump right in and do this. All right. Hi, everyone, and welcome to Moon Society's 2023 Lunar Development Conference. I'm Ben Smith, co-host of this conference, Moon Society treasurer, and founder of Lunar Homestead. Today, I'm going to talk about lunar frontier enabling tech, what it is, how it's different from our current tech, why it's critical for the rapid settlement of Luna and locations throughout the solar system, and how you can help make space settlement a reality. So what is frontier enabling tech? The tech part covers both technology and techniques, the hardware, and how we use the hardware. Most people focus on the technology, and that's understandable because it's something you can hold. You can design it, build it, test it, sell it. Space technology is the sexy part of space exploration and settlement. It's all high tech and shiny. And it's also the easiest part if you don't have to factor in the next two components. The techniques component is just as, if not more, important than the technology component. Technology alone isn't going to be enough. We've already got a lot of the technology we need to live and work on Luna, at least for short durations. However, almost all of it is inadequate for sustainable lunar settlement. And that's no surprise because it wasn't designed for settlement. It was designed for short-term exploration. And in the case of the International Space Station, constant resupply from Earth. We'll have to rethink everything if we're going to have a chance at settling the moon. Not just modify current designs, but explore other ways to do things. The current paradigm isn't necessarily the best way, and it sure isn't the only way. And it hasn't produced the results we want. Albert Einstein defined insanity as doing the same thing over and over and expecting different results. However, the frontier enabling component is, in my opinion, the most important. All the technology and techniques must be designed around the concept that frontiers are difficult, dangerous, and resource constrained. That's true for frontiers on Earth, Luna, Mars, or anywhere else. Otherwise, they wouldn't be frontiers. And the best way to thrive on a frontier is to be as self-reliant as possible and to manage your expectations. So the frontier enabling component is the rules used when designing space settlement tech. And I'll cover those in the next slide. But you may wonder why managing expectations is part of the tech. It's actually pretty important. We've all been immersed in fiction that depicts space settlement in very positive ways. High tech, clean, relatively safe, cool jobs, fun, et cetera, et cetera. And that may be accurate for mature settlements. However, frontier settlements will most likely be very different animals. Restricting our technology and techniques to achieve this fiction is at best slowing us down. We must explore all the possible tech, even if it doesn't align to our preconceived beliefs of what lunar settlement must look like. Developing a set of rules will help keep us on track. Basically, don't expect lunar settlements to look and operate like they came out of Star Trek, and don't rely on Earth to keep lunar settlers alive. Okay, so what are these rules? I only have time to cover a few of them, and there's more information on the Lunar Homestead website. The URL is in the corner of the slide. The most important rule is local manufacture and maintenance. Ideally, all the tech needed for survival can be made and maintained using materials obtained from the settlement's local environment. So all the equipment is designed to be built on site, and it has to be designed to be serviced and repaired on site. And all the components that make up that piece of equipment must be designed to be manufactured on site using locally available resources. And those components must be designed to be serviced and repaired on site as well. It's a daunting task when you think about all the tech that would go into making a lunar settlement. In situ resource utilization, habitat construction, energy generation and storage, life support, and so on. The list is actually quite extensive. And that's just half the problem. The other half is selenology. Many of the materials that we've come to rely on are either rare or non-existent on Luna. For example, anything designed using copper isn't frontier enabling. According to the Lunar Sourcebook, the highest concentration of copper we've found so far is around 60 parts per million. It would take a lot of equipment, energy, and effort to extract enough usable copper from the regolith, and we would have to move and process a staggering amount of material to do it. On the other hand, aluminum is the third most abundant material on the moon, making up about 10% of the atoms in the highlands. Only about 4.5% in the mare, but that's still much more than copper. So we'll probably use aluminum to conduct electricity, but we can't simply take an existing piece of equipment and swap out the copper parts for aluminum. Aluminum behaves very differently than copper, so everything will have to be designed from scratch. And this is just one simple material. Most of our current space tech uses some pretty exotic stuff that lunar frontier settlements won't be able to make, at least anytime soon. We basically have iron, aluminum, titanium, calcium, silicon, magnesium, and oxygen to work with, along with bulk materials like basalt. Solving for just this rule alone is a huge challenge. And to make things even more complicated, just behind that in importance is tool local manufacture and maintenance. And this is often overlooked. Not only must the equipment be designed so settlers can build and maintain them on their own, the tools needed to build and maintain the hardware also must be designed so settlers can build and maintain them on their own. There's little point in making the equipment frontier enabling if settlers still need to ship their tools from Earth. The example of this that I always think of is 3D printers. It might be possible to manufacture or even print most of the bulk components. However, the complex electronics that actually control the printer would still have to be shipped from Earth. This is why I'm a fan of simple manual tools. And finally, at least for this presentation, is local resources only. We've established that the equipment and tools need to be made from local resources. This rule requires that all processes also must use local resources. Unfortunately, we're probably going to have to break this rule once in a while because Luna just doesn't have an abundance of some critical materials. Let's take carbon as an example. So far, we have found very little carbon on the moon. There are extremely small amounts in the regolith, and there's evidence that cold traps might contain some carbon dioxide. But we haven't ground truthed it yet, and actually extracting it will probably be a difficult challenge. But our settlers are going to need carbon, at the very least for life support and agriculture. There's no getting around importing carbon, at least until somebody starts mining the permanently shadowed regions. However, we can make sure that carbon is only used in processes where it is absolutely necessary and can't be replaced. And if it is used, that it's not consumed by the process or permanently locked up. I'm looking at you, Steel. The goals of these and the rest of the rules are to significantly increase the settlement's long-term safety. Any reliance on Earth is a vulnerability. All it takes is another pandemic or global financial crisis or large-scale war or any number of other threats to stop critical shipments reaching lunar settlements. Settlers might be able to tough it out if it's a short-term problem and if they have a big enough stockpile. Otherwise, they're looking at either figuring out a solution that doesn't need Earth, abandoning their home and going back to Earth, or dying. We might as well save them the drama and figure out solutions now when nobody's life is on the line. Increase the speed they can grow their settlement. Settlers that can build everything they need can control how fast their settlement grows. On the other hand, settlements that depend on Earth for critical equipment are at the mercy of manufacturers, supply chains, logistics, launch schedules, and politics. Plus, this will decrease their financial dependence on Earth. Buying stuff from Earth and having it shipped to Luna is a money pit for settlers. One of the biggest hurdles for space settlement so far is that no one has figured out how to make them profitable. I'm not claiming that I have solved for that equation, but reducing the ongoing expense of operating and growing a settlement will go a long way towards making them sustainable and profitable. I was going to go into more detail for this slide, but it made the presentation too long, so I'll just hit the highlights. We should use the lowest tech we can get away with. It's easier to design, build, and maintain lower tech equipment. We're more likely to be able to use local resources. A lot of high-tech solutions require high-tech materials, manufacturing processes, and tools. And low-tech solutions make good backups when the fancy toys eventually break. And mass and volume stop being factors when settlers can not only build the equipment on site, but can also build pressurized space on demand. And simple equipment has a lot of advantages, but one of the most important is that most settlers should know how it works. The tech shouldn't require advanced degrees to maintain and operate. So let's look at one example. One of the most important components for a settlement is the habitat pressure hull. You can't have a settlement without people, and you can't have people without a pressurized space. There are several popular habitat concepts, so let's see if they are frontier enabling. However, there are a couple of things to keep in mind. All of these options are completely hypothetical. As far as I know, nobody has built and tested any of these, let alone actually deployed them on Luna. There is a lot we don't know, and some of what we think we know is going to change. All of these options might be perfectly valid for establishing a base, outpost, whatever you want to call it. Bases and settlements have different sets of criteria. Bases might actually be designed to be dependent on Earth. You wouldn't want lunatics to get any pesky ideas of independence, right? And finally, these settlements could be valid for establishing, or these concepts could be valid for establishing the initial settlements. Drop a habitat, basic ISRU, and everything needed to keep a few people alive. Then the settlers build the real settlement using frontier enabling tech. Eventually, they'll reuse, salvage, or abandon the initial equipment in favor of their new sustainable settlement. So let's look at 5 options. The first is pre-assembled. These habitats are built entirely on Earth and shipped to Luna as a single unit. As you can see, it fails most of the frontier enabling rules. There's no way settlers could build or repair these habitats. The hull would most likely be aluminum alloyed with elements that are rare on Luna. The tools needed to create and shape this alloy would be impossible to make locally. The whole thing is pretty high tech. The one advantage of this concept is that the habitat is ready to go day one. It doesn't get much simpler than that. Inflatables are also a rather popular concept these days. The big advantage is that they are less volume constrained, meaning that you can ship a larger final volume in a smaller initial space. And that's about it. These things are made with high-tech fabrics such as Kevlar. Not only does the moon lack the resources to make these fabrics in large amounts, the tools needed are also pretty exotic. Settlements won't even be able to make the patches needed to make the inevitable repairs in their hull. The whole thing is high-tech from start to finish. And deploying the thing won't be simple. The ground beneath it has to be prepared. Large rocks must be removed, and the ground has to be graded and smooth. That will require even more high-tech equipment. Then it has to be unpacked and spread out, probably staked down to help maintain its shape. Some concepts even pile regolith on top before inflating it. I don't even have time to go into all the problems that dealing with regolith creates. And then we got 3D printing. And 3D printing is the current flavor of the month. And I will admit that it's a pretty neat technology. But I'm not sold that it's viable for making habitat pressure hulls. First, the concepts that I've seen use raw regolith as the building material. And let's ignore all the issues that regolith has for now. I don't see how raw regolith is feasible because regolith doesn't come in uniform shapes or diameters. Some sort of crushing and sorting will be necessary so the material will feed into the machine properly. This is in addition to moving all of regolith in the first place. The whole operation would be far from simple. The other problem with using regolith is that some sort of binder is needed to hold everything together. Usually some sort of polymer made from materials scarce on Luna. So settlers would have to ship it in. And how are settlers going to build more 3D printers if they want to expand their capability or repair broken printers? These things are pretty high tech because they are designed to operate on the lunar surface, which presents a lot of challenges in itself. So sintered regolith. Sintered regolith involves heating regolith to the point where the particles fuse together but are not hot enough to actually melt the regolith. Sintered regolith scores a yes on local manufacturing because all you need is regolith and no binder. However, the equipment needed is rather technical. Most concepts use microwaves to heat the regolith. I'm not a microwave expert, but my guess is that it'd be really difficult for a new settlement to build them from scratch using lunar-only materials. Plus, sintered regolith, like inflatables and 3D printing, will require a significant surface operation to support it. Okay, so lunar cast iron habitat pressure hulls is a project that I'm working on with Lunar Homestead. You can learn more about it on the Lunar Homestead website. The hull is made from iron extracted from the Mare megaregolith basalt. When you look up at the moon and you see the dark areas, that's all Mare basalt. It's a common material. And settlements located in the Mare are going to extract iron from the basalt anyway, because it's the easiest way to extract oxygen from the rocks. Forming the hull plate shouldn't require any advanced tech. Melt iron, cast it into shape, then weld the plates together. Humans have been doing that for a very long time. And since it's part of my shielded pressurized oxygen resource extraction or SPORE concept, it avoids messing with the regolith and minimizes surface operations, making the whole process simpler. I'm not saying that this is the only way to go, but it is an interesting option. Frontier enabling tech could be the key to a future with many lunar space settlements. In the short term, we eliminate at least 3 bottlenecks. I like this image, breaking bottlenecks with ideas. First, we remove large governments as the only actors for lunar settlement. Any group should be able to buy this tech, buy the transportation needed, and go create their settlement. In fact, the ideal future would have multiple manufacturers of lunar settlement kits that groups can purchase. This tech would also allow smaller governments to get involved in space as well. They can use the kits to build their own national bases instead of relying on one of the major powers. Second, we break the technology bottleneck. We really need to break out of the constant research and development cycle we've been stuck in for decades. Have you noticed that everything has to be bleeding edge when it comes to space technology? Spend a lot of money and time developing something, use it once or a couple of times if you're lucky, and then move on to the next better idea. The frontier enabling way is to make a Mark I gadget that works well enough and use it for every settlement. Sure, make incremental improvements if necessary, but stop constantly trying to replace it with something better. I'm not saying NASA shouldn't be doing space settlement R&D. It absolutely should, because that's what it's good at. But NASA shouldn't be tasked with actual space settlement. NASA and other organizations should do the research. Manufacturers and settler groups would use that research at their discretion. Finally, we can eliminate a lot of the uncertainty related to lunar settlement. Technical uncertainty, because we'll finally get off the R&D hamster wheel. Right now, it's impossible to actually design lunar settlements because none of the hardware exists. There are no technical specs or on-the-shelf examples. By building all the necessary Mark I widgets and sticking with them, we can then build actual systems, which in turn can be put together to build an actual settlement. Until we have technical certainty, all settlement designs are wishful thinking and fiction. Financial uncertainty, because we'll have actual hardware. Settlement groups and their backers will have hard financial data on what equipment is needed, how much it will cost to buy the equipment, what's needed to grow the settlement, et cetera, et cetera. And since we'll know specifically what needs to be sent to the moon, we can also calculate the transportation costs. Right now, nobody wants to invest in space settlement because almost everything is an unknown variable. It's just too much risk. If we retire enough of these unknowns, the money will start showing up. Removing just these three obstacles should really speed up the initial settlement process. However, the long-term effects of lunar frontier enabling tech is where things get really interesting. If established settlements can build tech for themselves, then they can build and sell the equipment needed for new settlements. This could be an important income stream for lunar settlements, which eliminates even more financial uncertainty. If we're really clever and we build the tech right, we might be able to almost completely remove Earth from the space settlement equation. One settlement helps build two settlements. Two settlements each build two settlements. And those four settlements each build two settlements. And I've run out of space, but you get the idea. Pretty quickly, the moon will stop being a frontier and be just another place to live. What's more, settlers heading to Mars, an asteroid, Jupiter system, or beyond can buy most of their gear from lunar settlements, gear that has been proven to work on the frontier, gear that we know so well that it's easy to modify it to work wherever their new home will be. If we're clever and persistent, we can go from a single planet species to a solar species relatively quickly. Imagine that future. Okay, so how are we going to get from here to there? Lots of research and hard work and money. And unlike the current paradigm, you can actually help shape this future. Here are a few ways. You're already a member of the Moon Society. Thank you for your support. That's a good start. However, there are other organizations working on space settlement. The reality is that we can't rely on governments or businesses to create the future that we want. It's up to us. The first and easiest step is to give a few dollars or kroners or whatever you like each month to organizations that are doing space settlement work. Pick ones that you find interesting because maybe you'll want to volunteer. Most of the organizations working on lunar settlement are volunteer run, or they have a very small staff. I know the Moon Society has several open volunteer positions that you can help with right now. And most importantly, research. There are not a lot of people working on lunar settlement research. Even less are working on frontier enabling tech. There are many opportunities for amateur scientists to contribute in a significant way. You don't need a PhD, a fancy lab, or even a lab coat. It's as simple as picking a specific question, document how we solve for it on Earth, then figure out in detail how lunar settlers could solve for it. You can put all your research on the Moon Society's Lunarpedia website. You'll advance our knowledge in a real way and help other researchers push the tech forward. All you need are access to the internet, curiosity, and persistence. And the internet is optional. That's it. Lunar frontier enabling tech plus determined settlers equals lunar settlement. Basically, create the right tech, give everyone access to it, and get out of their way. Next time you see a piece of space tech, ask yourself if it's frontier enabling. If it's not, think about how it might be modified. If it can't be modified, think about other ways to achieve the same goal. Those of us that want to see lunar and solar settlement need to stop being spectators and cheerleaders and start doing the work that will get us there. Because if we don't, we may lose our window to make it happen. Thank you. Any questions?
Thank you, Ben.
I'm going to stop sharing.
And we do have plenty of time for questions. So anyone who wants to ask something? Okay. So what's the first step?
First step is to start designing and building out some of the more basic tech.
I mean, what is the first tech to start building?
Oh, I think we need to hit it from every angle. I mean, if you think about settlements, there's literally thousands and thousands of things we need to solve for. Something big like, how are we going to extract iron and oxygen from basalt, to something small like, how are settlers going to brush their teeth without having to import toothpaste? There's all kinds of day-to-day activities that we take for granted that settlers are going to need and or want to do. How are they going to do that without spending a lot of money importing stuff from Earth?
Yeah. So essentially, start in all places at the same time. There's a lot of things to do.
There is a lot of things to do, and that's why I say that those of us that want to see this happen need to do the research, because you can guarantee that the big national organizations, the companies, they're not going to figure out how settlers are going to use deodorant or make soap or all the other stuff that's necessary. And that's stuff that we can work on. If you have a hobby of soap making, you very easily could figure out how they can do it on the moon, and then document it and get this stuff on record. Because a lot of people say, oh yeah, we'll figure that. That's easy. Well, but it's not done. So let's get this stuff done first, so we don't have to figure it out later on when we're actually ready to start building settlements.
Yeah. Soap, making soap without copper. Now we do have a question here from Chris. Regolith simulant contain relatively large amounts of aluminium and titanium in addition to iron. Have you considered using those as hull metals? How does the processing for those metals compare with the effort of creating cast iron?
Right. Thanks, Chris. Yes. Well, it depends on where you're at, right? So if you're in the Mare, you're going to get basalt, which is more iron, less aluminum. If you're in the highlands, you're going to get much less iron, much more aluminum. But it comes down to energy, right? Resource constrained. So especially early settlements, but for a while, settlements are all going to be energy constrained. And it takes less energy to break the chemical bond in iron oxides than it does for aluminum oxides than it does for titanium oxides. So it's just a matter of energy. So the first thing that I think that settlers are going to do in Mare locations is break apart that basalt and break apart those iron oxides, because they're going to want the oxygen too, which means they're going to have iron. And so why not use that to make hulls?
Yeah. Any more questions?
Okay.
Other question from a technical question.
Oh yeah, I saw that. I don't know how to help with
what
that
are
one.
the locations? There is a question. What are the locations you would consider for settlements from Marufa?
Right. So everybody right now is looking at the poles, right? Because that's where the PSRs are and theoretically where the water is. And I think that we should be looking at settlement everywhere, in the Mares, in the highlands. Right now, I'm focused in the Mares because that's where the basalt is. I think ideal settlements, there'd be several ideal places. One would be where there's a Mare highland interface. So settlements could get access both suites of materials. The other ones would be where there's interesting places, like maybe where the mascons are. Start digging down, see what's there. You can maybe find pure iron or pure metal instead of having to, extract it from the rocks. So I think there's a lot of really interesting places to put a settlement besides just where the PSRs are.
Mm-hmm. Ulf has a follow-on question on that. And what about access to nitrogen for life support?
Yep.
That kind of requires deep freeze, doesn't it?
Now, well, here's the problem. So we need hydrogen, nitrogen, carbon. Those are the big three. And maybe we'll be able to get those out of the PSRs, which is the permanently shadowed regions. That's the cold traps where these volatiles may be. But there's a whole lot of unknowns with getting stuff out of the PSRs right now. And it's a very cold environment that we've never operated in before. So those three are going to have to be imported, at least for the long term. If not from Earth, then maybe eventually from other sources, but figure from Earth. So figure all settlements would probably have to bring in a shipment of ammonia or methane once in a while, and then they can crack them and they'll have hydrogen and carbon, hydrogen and nitrogen. Those kind of break the whole, self-reliant rule, but that's just kind of the way it is. The moon just does not have enough of those resources.
Except possibly in the permanent shadow craters.
Yeah, but I mean, everything involved with the PSRs is just a big question mark.
True.
All right. Well, it's 9:30. We should probably roll on to the next one. Thanks, everybody.